Right. Um, so welcome back. I guess I'm gonna try as we go through the agenda.
Sorry, I can barely hear you. Anyone else have the same problem? Or is it just me?
Same thing. I think got the wrong microphone there, Kyle.
Is that better?
Much better.
Okay. Yeah, so this time as we go through the agenda, I'll try to give like a brief summary just for the people who watch the video after the fact. And I mean, today we don't have any newcomers, but you know, just to keep people up to speed if they haven't been to every meeting. So I guess the first thing is the I guess projects and design docs. I did a little bit of reorganization. The links are there in the minutes. But like we talked about, I moved the triage project to be FluxML org-wide. And I got to move over like the issues to the new project, but now we will no longer have any of those forward pointer type things. And then I also moved the design docs, used to be in the FastAI.jl repo specifically. I moved those over to the ML tracker repo since now we've kind of expanded our design aspects beyond what would have been in FastAI. That's all I had for that. I guess the other announcement is on the last committers meeting, we checked with Daria, and he would be very happy for us to take on some of the maintenance burden for like the non-core repositories. So this would be something like the ML Zoo or the model zoo. We could go through the issues there or PRs, review them, and then, you know, after we're done with the review and we think it's ready to be merged, we can just, you know, ping Daria and he'll merge it. So that hopefully should get a better turnover on the issues and PRs for those kinds of repos. I think like Metalhead and stuff is within scope for that. Then in terms, I think we can also review stuff for like Flux and Zygote if people feel comfortable doing that, but I think that'll probably need one of the core maintainers to do another, you know, Passover before they actually merge stuff.
Is there anyone beside Daria right now?
Carlo is, I guess, the other main, Carlo Lucibello. Yeah, is the other main maintainer that I know of.
And who's working on the new auto differentiation?
That would be Keno, but
Keno, okay.
Yeah, I don't think that's part of FluxML as of yet.
Uh-huh.
Yeah. Nor do I know if that'll end up being part of FluxML. That might be a more generic AD package that we like transfer over to. So I'm not sure. But yeah, and then I guess that's all I really had for general announcement kind of stuff. I guess the next thing, or did anyone have any other questions on that? I guess the next thing is for the documentation. Someone added a link to a pull request for the FluxML website. This is basically the summer, like the Google Summer of Docs student is working on updating the FluxML website with tutorials and things like that. And I think it is a good idea that we should sync up with them. my thought was basically, I think there's one student working on it, so maybe we should ping Daria and see if whoever's interested from this team can have like a voice call with that student and Daria. I think that's probably the easiest way to just sync up.
I posted that because I noticed on that PR specifically, the student, I think it's Liniana, has links to like deal pipelines and a lot of stuff we talked about in these calls. So obviously that information is coming from somewhere. And if it's, I mean, best it come from directly from the source, right? To make it easier to coordinate that kind of thing.
Yeah. Yeah, especially making sure that stuff is like up to date as we make bigger changes. Yeah, I'm also thinking when we do that sync up, it might be helpful to try to have like a single issue that's tracking all these documentation changes, because some of them are to the Flux docs and some of them are to the Flux ML website. I don't know if anything will be added to the model zoo, but if the model zoo turns into like that weave style situation, then there'll be tutorials and stuff there that are actual documents. And so, yeah, maybe having a central issue that's tracking all of these changes will also be useful.
I just like the, what do you call it? The CSM of docs description for what the FlexML task is. It seems to be constrained to the website, but I mean, there's no reason why it can't coordinate with that on the actual repo docs as well. It doesn't say getting started tutorial. I mean, that's a potential area to collaborate on, because getting started with Flex right now, the 60-minute blitz, for example, says nothing about data handling other than you have to do it yourself. And that's something we've been looking into a lot. Another area is, let's see, the whole reorg as well. Posted the link about the ecosystem docs, but I'm sure there's more sections to talk about there in terms of like high level libraries. I don't see any in there, right? Flex training would obviously fall into that bucket. And there's not too much to work with here, but based on what I've seen in the website repo PRs, there's a lot of places we could pop in if we wanted to.
Yeah, so I think especially that'll be important once our stuff stabilizes a little bit. Like we talked about on the last committers call about kind of how the FastAI docs approach is, I guess, top down. So it's like at the most beginner friendly view of the ecosystem, and then it like narrows down towards more advanced techniques. Whereas at least right now, the Flux docs go bottom up, so it shows you how to take, at lowest level, the gradient of arbitrary function with arrays, and then builds up to like a standard ML pipeline or standard ML model. And so we'll probably, reverse that ordering if we basically update that whole getting started to reflect the changes that we've done.
Yeah, and I mentioned this in the call as well, but there's even a third approach, or I don't know if you'd call it a moderate approach between the two, but the PyTorch docs have a reference, and then a entire tutorial section, which is purely just tutorials on covering certain use cases. Not saying that's the best way to do things, but that's another way to do things if that we want to look into, perhaps. Especially because I'm looking at this project description again, and it says, where is it? Define a style guide for creating new tutorials. So, if with that gives people, people may not be willing to take up the task of doing like structural changes to documentation or like trying to figure out what goes where, but people will probably be a lot more comfortable writing a tutorial in a domain they're doing actual work in. And you can always clean that up. And eventually, if you want to assimilate it into some other part of the docs, then it's there at least.
Yeah, I think Chris brought this up during like the committers call. I think the best version is where you have an API section where you just have reference to every single doc string, structured if it needs to be, and then but then the rest of the documentation or the bulk of it is in the form of these tutorials, where maybe you repeat stuff that's already in the API section, but it's okay if you repeat it. It's better to repeat information in the docs than to try to be too terse about it. Yeah, so I think definitely, I guess people might be less inclined to do the structural changes, but maybe the structural changes that we could do is to solidify a good API section and make that reorganization. And then, I don't know if the basically coordinate that process with the summer of docs so that whatever sample template for tutorials mentions a little bit about what you said just now, where you should have like linked pointers to the references in the tutorials so people can dig deeper and things like that.
So I have a question. Should the documentation on the Flux website also include packages like beside Flux? So like supplementary packages like Flux training?
I mean, there's a section for that right now.
Yeah, so if you go to that pull request, I think that's already there, but if you go to that pull request, that's a large part of what it addresses. It has basically subsections for different topics, whether it's like something specific like NLP or probabilistic programming, or it's stuff like plumbing style packages, pipeline packages, and then it has forward links and a short description of the package.
Yeah, I didn't mean the ecosystem section, but the tutorials themselves. Because I think on the PyTorch website, most of the tutorials are just written in plain PyTorch. And of course, on the FastAI website, they can do, make tutorials on specific topics a lot more easily because they have a lot of the plumbing for, data pipelines and data sets, and then focus on the one part of the API that they want to show off, which, I think in some of the PyTorch tutorials, it goes over a lot again and again.
Yeah, I mean, I think let's just take Flux training as an example. No, Dario, we can't hear you. Let's just take Flux training as an example. The bulk of the tutorials around that would obviously be in the Flux training docs, but I think there are certain packages or certain workflows that are, I guess, so standard or basic that
Hi.
we can hear you now.
Okay, beautiful. So just wanted to make a couple of clarification points on where the documentation should go and you know the structure. So I believe there is a plan either in the next couple of days, either today or tomorrow, to uh, basically make that models page a bit more, organized. So like dividing it into, oh, these are things for pipelines. This is how you work with data sets, augmentation things, libraries, all of that. That's one part. Second, on how where documentation for things like Flux training and stuff might want to go. So we already host things like Zygo documentation and even I think a couple of other packages on the FluxML website directly. So it's on the same domain. So we can definitely have the FastAI and Flux training and things like that also have their own subdomain. So we can make sure that we're following the same guides and you can have uh, all the good whatever tutorials that you want to write, they can be hosted in like a consistent code quality and structure and stuff like that. So that's probably already in place. Um, we also have the Flux bot. Actually, if I can ask for help from someone to just, it's a fairly simple task. Um, just need to port the Flux bot. Like it's just a little package which will pull in certain requests, and then we can, using github.jl, just make sure that we have everything in place. So you can push PRs to the website and such for modeling and CI and stuff like that. So that way we can, make it a bit easier to. Anytime you have a new tutorial, you can just do something like a Fluxbot release docs or something, and it would just do that. So rather than just with releases, you can also do it, scheduled for our needs. So that's definitely a way forward. Um, yeah, and for how documentation should look like, as Brian mentioned, a more moderate approach or a bottom-up or a top-down, that's very dependent on the kind of things that we want to do. So from an API perspective, I definitely agree that we need to be pointed at to call, but I would be interested to know how people want to see, you know, things like lumping, right? So like pipelines. How do we want to project? This section is specifically for pipelines, and this section is specifically for like making your own model or whatever. So, or how do you use the learners properly? So that's one question that's still a little bit open to me, and maybe Peter or Lawrence or whoever might want to comment on that. That'd be brilliant.
So my suggestion would have been to have the high-level tutorials that make use of a lot of the additional packages next to Flux.jl as part of the FastAI.jl documentation, because that's the package that brings them together, and then it has probably its own high-level APIs on top of that and the stuff it implements. And then people can just install, like add FastAI and actually follow the tutorials.
Yeah, I agree. Making it simple is good.
Yeah. Sure. I mean, that's basically on the same level, right? So like you can have the Flux training documentation alongside the FastAI documentation. That's absolutely fine.
Yeah, and I guess the package specific documentation like Flux training would still contain the more detailed information on how it works and how to extend the interfaces. But then the high level tutorials where you pull in other libraries as well to show off I guess could be in FastAI.jl. I think that would make sense.
So I think that makes more sense as a tutorial essentially, when you're showing, how multiple packages work together.
Yeah, I mean like high-level tutorials in FastAI.jl.
Yeah,
Right.
and specifically for and extending the interface. One thing that we usually do with Flux is that we definitely have that as part of the documentation as well. So we'll probably have to see how feasible it is to do the same style basically, because you generally want things to be general and flexible, right? You don't want um, to have very hard assumptions. Um, so yeah, so we can definitely discuss on those topics, but that's a separate discussion.
So one thing I could do is set up a documentation project in FastAI.jl and add a tutorial, and that could be a place to like a high-level tutorial that uses all the libraries. I think basically what is in deal pipelines right now. I'll just share it. Because that's like an end-to-end tutorial using like a data set, using Flux training, using deal pipelines, and like training an image classification model. It doesn't actually show the training because it's built on the GitHub Actions computer, so it doesn't have a GPU, so it doesn't do it, but kind of in that fashion. And there's like in this case, there's a section with like 8 package add calls that would be redundant then if you could just add FastAI.
Yeah, I mean, I think, well, first, FastAI, I guess, still needs to be updated to start using Flux training and everything. But so I think having a high-level tutorial that just does using FastAI and then uses all the interfaces in FastAI to train through some pipeline is good for high-level tutorials. I also think there should be tutorials that I guess aren't as high level, are like mid-level tutorials that apply to the packages that FastAI it brings together. Because I guess not every use case is going to necessarily use FastAI, right, as their package. They might just be interested in data loading or data augmentation without using the FastAI library, but they just want the de facto way to do that.
Do you mean as in the like in the Python FastAI documentation, they have beginner tutorials, which are basically the high-level 7 lines of code, train an image classifier kind of stuff, and then they have the more advanced tutorials that go into the different APIs and how to extend them. Since the mid-level APIs in FastAI are kind of like the different packages now.
Yeah, I mean, I guess the point is that FastAI, at least in the Python land, is effectively like a monolith package in terms of the fact, like you're working completely within the FastAI ecosystem. Whereas what we've created is an ecosystem that's, I guess, more flexible, and you're not constrained specifically to using FastAI. You can use the parts of the ecosystem independently. So kind of like what Daria was saying is that under the FluxML website, we can have separate subdomains for all the docs. I'm thinking that for the most part, all of those packages should have their own documentation, and like the mid-level tutorials that are specific to those sub packages belong with their documentation. And then you'd have high-level tutorials in the FastAI side of things that tie all of that together. But I also think that there should be, I'm thinking that most people are going to go to the flux.jl docs before they go anywhere else. And so I think the Flux docs themselves should say, oh, here's a snippet of how you would do data loading, you know, and then a forward pointer to the data loading packages docs, right? Or in the very introduction of the Flux docs, it should say, you know, if you're interested in a really high level API, you should look at fastai.jl or dlpipelines.jl and link to those, basically.
Yeah, I think a forward pointer to the high-level APIs would be helpful. I think especially for new users coming from Python FastAI, they're kind of expecting a high-level API. Maybe if they're don't know a lot about deep learning yet, then they probably won't want to dig directly into how to take gradients. And they, like, imagine someone has taken like the first 2 or 3 lessons from the FastAI course.
Yeah, and just
So
to
one
second Kyle's
Yep,
point.
just go ahead.
Oh, sorry. To second Kyle's point, if you go to the FastAI documentation right now, you still need to know how to use PyTorch. And there's this discontinuity between the FastAI docs and the PyTorch docs,
Yep.
which is pretty unfortunate because they're two different websites. They have completely different styles. There's no linking between the two of them. And so in this case, we have an opportunity to make kind of a continuum where each package has a reference documentation and say like good examples and like maybe even small end-to-end samples for its own functionality, but we can like coordinate between those to have like higher level packages can cover higher level functionality, and if they don't need to, you know, cover taking gradients because they could just link to Flux, how to take gradients in Flux Zygo, and then similarly Flux doesn't need to tell you how to get your data into Flux. It just needs to tell you that you have data of this shape, and then here are some forward pointers to libraries that can help you get your data from into that shape.
So that, I guess my thought was very, very similar, just coming from a very different point of view. And that is that, as you mentioned, that there is this discontinuity between what FastAI does and what PyTorch does. And fundamentally, they're two very different, you know, things, even though one builds on top of the other. The thing that I want to kind of also cement is that we don't abstract out so much that people are no longer able to, you know, go and hack into the meat of the matter, right? Because that's kind of how we've developed so far, right? So as someone mentioned, that it makes complete sense that, you know, when Flux says that, oh, this is how I want my data to be presented, and here are A, B, and C libraries which can do that, or like you want to make sure that your memory bandwidth is utilized fully. So well, this thing will put it automatically in a channel or whatever to interact with the GPU. That's all great, right? At the same time, we should be transparent enough to make sure that people who are, you know, trying to solve something which isn't entirely done by the package or whatever can still get to it through the doc. So it's not like a black box again that they're, you know,
Yeah,
seeing.
That I think that's the primary way that we're better than Python and PyTorch, is that we're not, it's Julia all the way down, and you can look inside everything and change everything.
So this is a little bit different from actually even that, right? Because assume that you have this learner type from FastAI, right? And it takes in parameters A, B, and C. Sure. So it takes those arguments, sorry. That's all fine and good. But then all those parameters have to be constructed out of constructs from within FastAI, for example. And then you hit this wall again where people need to know what every single one of these things is doing to make proper use of it. I'm saying we should also be able to educate people that you can write your own version of this little thing here. It could just be an anonymous function for all we care, right?
I think,
So
yes, sorry, go on.
yeah, so like when we give people the flexibility, it psychologically brings on the notion that they are in control of what is happening. So like they understand what every single step is doing, so that way they can make better decisions about what part of their pipelines they want to tweak and how. Even though if they'll end up using the same high level constructs, that's absolutely fine by me. But in this way, it's much more clear about we're much more transparent about what it is that we're building in some ways.
Yeah, that makes sense. I think there's also an advantage of having packages instead of a monolithic package or more like framework that FastAI is, because that way we can make sure that there are very clear like interface boundaries. As an example, FluxTraining.jl, it doesn't really have anything to do with the model itself or the data that comes in. Is totally agnostic. It just needs anything that iterates over the batches or whatever the model takes in. And likewise, data augmentation.jl only transforms data. And I mean, I've even thought about if FluxTraining.jl could be made agnostic of the actual deep learning framework, so no longer FluxTraining.jl then, and that's definitely possible. Not going to do that right now, but just to show that it's not trying to do anything that Flux already does. Just yeah, give you some abstractions to work with that, and then everything model building that you do in Flux doesn't really care about that.
I think this is contracts, isn't it? I think this is saying, I'd like to make my own learner. I'd like to make my own data loader, and you need a document and a way to test to see whether you've implemented all the functions and behaviors that a learner or data loader would need. So, this is a well, in other languages you have interfaces, for example. In Julia, really, it's documentation, and maybe traits. But
right. I mean, you have informal interfaces, but yeah, and you document them clearly. So
Yeah,
the packages should really be able to stand on their own and not rely on anything else. So
Right.
DL pipelines, for example, you can also just throw it into the vanilla Flux training loop, and it
yeah.
works.
I think the
One, if I may.
yeah.
So I think that's the right sort of direction in many ways. One little thing that I wanted to point out was that we should also, try to have a little bit of a benchmark, so to speak. Something like, are you able to train? Oh, I don't know. Take the ray tracer example, right? Take either the ray tracer example or the dolphin mesh reconstruction, or maybe even just the continuous normalizing flows fjord example from SciML. and see how something like that can fit into the FastAI model, like whether we can train those systems as well. So can we
Definitely.
remain
Yeah,
generic enough to
I
handle
mean, I
those
could try it
cases?
out, of course, but I'm 99% sure that it will work because the training loop is just the same, just with some extra like callback events sprinkled in. It's
Are these,
almost the same code as in Flux, the regular training loop. So everything that should work there should also work with Flux training.
are we talking about adding things that are not deep learning, machine learning that is something different than deep learning?
No, it's still deep learning models, just more ones with non-traditional training procedures like
More
your
differentiable
neural differential
equations, right?
equations.
Oh, excellent. Yes, we should definitely add those.
Because FastAI sucks at those in Python right now. I don't think it's possible at all to train in
I mean,
neural
I
ODE.
think that's a PyTorch issue, more right. And I mean, Flux already does that and does it great. And whatever we build on top of Flux or to interact with Flux should work with that. And I think it does. I don't think there's any reason it shouldn't.
Yeah, sorry, I should clarify. I think it's more of a training loop issue. For example, like the FastAI training loop is the FastAI Python training loop is very specific and opinionated in how it executes. And it doesn't handle stuff like multiple phases of training very well. I don't think it really, I don't know if it'd be able to accommodate like the adjoint approach you have with narrow ODEs very well at all, because it takes in a model architecture and just shoves data into it, all that kind of thing. But so that's definitely, if we can improve on that, that's a big win, right? Because then you get high level training primitives still, regardless of what kind of model you're throwing into it.
Right. I'm not very familiar with ODEs and the way stuff like defect flux works, or how it's different from the regular training loop with like regular deep learning models. But if one of you, maybe Brian or someone who knows it,
Oh, I don't know it either. I'm just
knows
participating.
more about it, then we
Yeah.
could see how it fits into Flux training.
Maybe we should talk to Chris or get Chris on the next call or something like that.
Eric could also do that if he knows more.
But even outside of
that's that would be a great example to contribute.
Yeah, but even outside of like differential equations, for example, I'm doing a lot of self-supervised stuff right now. And right now to do that in FSA, you essentially create two learners because there's two, you have to pre-train and then you have to do your training. So like, I mean, that's probably more the domain of deep learning pipelines, but still, like there are plenty of use cases. I'm sure we can dig up weird use cases like GANs training, which is really clunky in FastAI Python. Any sort of energy-based model, I think, gets a little wonky as well. That kind of thing. So, yeah, well, I'm sure we'll be able to find plenty of examples that break the FastAI canonical training loop.
Yeah, I think it might be helpful to have an issue that tracks all these different use cases and adding them. But all of what we're talking about in terms of documentation or where it goes, I think should go in the model zoo. Because that's the most central place for someone who comes in and says, oh, I'm trying to do X. They're going to, or right now and in the future, they'll look to the model zoo for an example of that. So, and to Daria's point, if we do stuff like that, we can also, benchmark the performance of it, once we get benchmarking running on the model zoo.
Yeah, so I think a lot is just porting tutorials, writing tutorials, trying out different things. I think especially with the things that where Flux excels and PyTorch doesn't, I think that would be great to have some tutorials there. Yeah, if I, probably possible to integrate everything with Flux training, but if something doesn't work, you can always come talk to me, of course.
Okay. We have like 15 minutes left, so unless there's some more pressing issues on this topic, maybe we should move on to the last two. So I'll just switch up the order here a little bit, since we don't have any MLJ folks with us, but there's a link in the minutes to, I guess, the work in progress documentation for data augmentation.jl. I guess the most relevant thing for this pipeline will be, I guess, the medical stuff that we were talking about last time, right? We were talking about that medical use case, and I think the bulk of what that use case made up was, one, loading 3D data, and then two, applying a bunch of an augmentation pipeline to it, right? So maybe now that we have these docs up, it might be a good time to work a little bit more on that user story. Does that sound right?
Right. So I had a call with Dale like 2 weeks ago, where we went through the tutorial together, and we kind of wrote down in the issue. Can you link it? Do you have it there? Let me see. Tracker. In the issues, what needs to be done, which parts of the tutorial can be covered with which libraries. Okay, I have the link. And yeah, like the progress on each of these. And let me see. I mean, so it's kind of broken down into like loading the data set, the actual augmentation pipeline, the model, and then the training. And there's really not that much that is missing. I think the biggest part is probably the loading the data set itself. The data augmentation part, since from what I understood, it's not really a 3D image. It's more like slices of it's 2D slices, like the same number of 2D slices of a 3D image. And they're only transformed in the same way as regular images are. So that should already be possible now to do with data augmentation.jl. And yeah, there maybe you can try it out, have a look at the data augmentation documentation that I already put up. And yeah, maybe you want to say something more. Did you get any further?
Yeah, so I worked on 2 weeks ago, I worked on getting the data loaded and all that stuff, and came up on some problems with, I think it was just because this data augmentation docs, were they up 2 weeks ago?
No, they're up since 4 hours ago.
Okay, gotcha. Yeah, so the data augmentation side, I got stuck on. So now that those are up, I'm excited to go back to it. The thing I've been working on is, in order to do this for my PI, he's going to want me to produce some sort of paper on this. And so I've been working on, okay, how do I get a paper out of, how do I manipulate a paper out of working with Julia? So I've been doing, I've been loading everything into PyTorch, making it exactly, because I discussed with you the loss function that I've been working on. And so the loss function is computationally expensive and all that stuff. So the past 2 weeks, I've loaded it. It's all done in PyTorch. And now that I think the data augmentation was the only thing I was waiting on. So now that the data augmentation is ready, I'll try and do it in Julia, hopefully get it faster, and then produce a paper. We'll see.
Yeah, I mean, for that kind of goal with the paper, I mean, I don't know if you have like a specific venue you're looking at, but in general, if you're trying to squeeze out a paper out of doing something in Julia, like I'm looking at the to-dos on this GitHub issue, and it seems like on the data container side of things, the augmentation side of things, and I guess even on the training end with the loss function and everything, there's a couple pieces that are standard or like standard for this specific user story or medical use case. And I could see there being basically a package that provides those in Julia. So if you were to write, if you were to get it to work in Julia and then you package it all up into a package, certainly you could manipulate the creation of that open source package into a paper. So yeah, if that's your end goal, I think that would be a good, contribution and help you out as well.
Yeah, my end goal is to get our lab slowly shifted over to Julia, but to do that, I have to produce some stuff for my PI. And so I think this is a good start because, yeah, like you said, just the basic tutorial is going to be the majority of what I need to do because I already have the loss function and that sort of stuff. So a package is a good idea too.
Can I ask if you have a venue in mind already? Because I know some of them are more results focused and some of them might be more interested in the algorithmic part. So if they're more of the former, you could get away with pretty much algorithm written in COBOL if you wanted to.
Yeah, I don't have any preference. I really, it's literally just going to be, okay, can I continue doing this so that way my PI is cool with me working in Julia, even though it slows us down often.
Fair enough, yeah. Yeah, I haven't even proposed doing that to my advisor, so that's good on you for taking the plunge.
Okay, cool. Well, I mean, that sounds like it's at least progressing well since the last time. Oh, looks like Ari has a journal suggestion for you. I guess unless there's other stuff related to augmentation, we can move on to the last topic, which is the stuff we've discussed with DL pipelines and MLJ. Since we don't really have any folks from MLJ here, maybe Lorenz, you can just give like a summary of the key points of that discussion.
Yeah, sure. So I'll just see if I can find the link to the Julep thread. Where is it? The pipelines. No. Link. Okay. So it was the thread where I published or sent a link for the first version of the documentation of view pipelines. And someone from MLJ also gave their thoughts. So the question was whether it could be integrated with MLJ and with Flux training and everything, how that could work together. And how I understood it, and what my suggestion would be, to use the MLJ abstractions to kind of wrap the learner from Flux training as an MLJ model, and wrap the data transformations from dual pipelines as MLJ, like static MLJ transformations. So then you could use MLJ together with those and use all the meta modeling and hyperparameter optimization that MLJ provides, and still have the flexibility of Flux training. And it hopefully can be done in a way that should just work, but I think so. and then you can use them together well. Yeah.
Yeah, sorry, I tossed this in more as a throwaway if we didn't have any other topics, but like one question that I'll have to bring up on Zulip again maybe is about like not necessarily integrating libraries, but sharing certain functionality. For example, if one library already has metrics implemented, then there's no real reason that we have to rewrite it every time, like all the Python libraries do over and over again, or wrap scikit-learn. But I mean,
true.
MOJ is effectively scikit-learn in Julia. Or at least having some agnostic library for metrics that's doesn't depend on any MOJ stuff and doesn't depend on any Flux stuff. Same story for example, if you wanted to define like something like if both frameworks use value histories, then they can interrupt there, or that kind of thing. Because integration might be a bit of a tall order, but sharing code is perhaps easier. And I mean, ideally, this would be in something like Julia ML, but Julia ML is kind of in hibernation. I don't know how to put it nicely. So yeah, just spitballing here, but ideas
Yes.
around that.
On that front, I mean, I've actually been successful in kind of reviving Julia ML a little bit. So,
Oh, nice.
I mean, the only reason I didn't put it in today's agenda is because I've just been swamped with work other than Julia stuff, and so I didn't get a chance to finish out those PRs. But there's a couple PRs there that modernize the Julia ML interfaces and kind of update the packages across the board to work with that new LearnBase interface. And I think Julio is updating LearnBase to have all those metrics and loss functions and things like that. So I don't know what the status of that part specifically, the metrics part is, but maybe we should ping him because maybe we can convince MLJ to use those, and then we can also use them, and then it'd be nice if we had a centralized set of metrics and like penalty functions and things like that.
Yeah, because somebody on Slack asked the other day where to contribute that stuff to, and I think they went to MLJ. But if we have something shared, so are they functions or are they like types that subtype like transform or learner or whatever is in the, I forgot the central abstraction there.
At least in the, I don't know about MLJ, maybe someone else can comment on that, but at least in the Julia ML.
And Julia ML, I mean.
Yeah, in Julia ML, I mean, there are type that subtypes, I guess, from like an abstract metric or abstract penalty.
Do we want that to make them types instead of functions?
Well, yeah, I mean, for me personally, I see value in having both. You know, I personally prefer the functional approach to the specific topic of metrics, but you know, in PyTorch land they're types, and I know that there are people who prefer having the types. There are things you can do with like projection operators and things like that on loss functions, and at least as I've seen those operators implemented, they usually work with loss functions as types. So you know, you basically make that operation inexpensive by creating a type and storing some information within that type that makes that operator possible.
Interesting.
Yeah. So I mean, but I personally would end up using a functional interface. You know, that's one thing I like about losses and flux is that they're just functions. but I know there's a desire for a type-based system.
Yeah, and perhaps not even like the functional forms are one thing, but there's also storing the history of metrics, updating them incrementally so they don't hog your batch or epoch end, which is something you don't get too much with the functional forms. I mean, FastAI kind of does it, but it kludges it by just storing all the predictions. So something like what online stats does. I mean, all that functionality it's kind of out there, but everybody does their own take on top of it right now.
Regarding that, so only updating metrics every few steps can be done with flux training, like throttling a callback. And since you mentioned online stats, actually all the metrics in flux training use online stats. And you can put in any online stat with different weights. They just what it's doing currently is it's just using the mean online stat and a function that it evaluates on the predictions and the targets, similar like to the loss functions that Flux gives you, and then it just uses like a mean from online stats, but you can plug in anything else.
Yeah, maybe I was thinking of as perhaps it's more of like a stretch goal kind of thing, but stuff where the mean doesn't work as well for like the cross-batch mean or cross-epoch mean doesn't work as well. So stuff like AUC or any of those confusion matrix metrics where the online calculation is a bit more involved to get like an accurate rolling online calculation rather than taking the mean or the rolling mean. But yeah, no, that makes a lot of sense.
Right. I'll just send the link to the section in the Flux training docs. Let me see.
Does Flux training have any, well, first, does Julia have any like logger support, like TensorBoard and things like that? And then will Flux training have like an easy callback for TensorBoard? Do you know?
There's a TensorBoard, it's a TensorBoard package. It's TensorBoard logger.jl, which does almost everything with TensorBoard. And there's also there's some logging callbacks in Flux training that you can use with TensorBoard, with the TensorBoard backend, and then it will log everything to that.
Awesome.
Yeah, TensorBoard backend, and send it on Logger. Actually,
Yeah, I mean,
1 second.
something with Maki for the 3D, or I guess 3D slices, however you want to look at it, but having some visualization like that would be really cool.
And that's definitely something I think Julia does better than Python, I think. I don't know.
Yeah, I mean,
it's written all in Julia, and you could manipulate it and compose stuff.
I mean,
to your heart's
I think
content.
it depends what you do with the data. So Dale, do you use 3D Slicer at all or any other IDK toolkit for what you do?
Yeah, we typically use like Vital, which is proprietary because we have that for free from our lab. But when we need to really dig down, we'll use 3D Slicer every once in a while.
Okay, because like not my lab, but our sister lab is one of the primary developers of 3D Slicer, and I wonder if it makes sense to ask them about a Julia SDK. I don't know even if they even know about Julia for that, but like Ari posting that reminded me of something like that because there's already a lot of functionality out there for working with medical image data specifically, and like there's Python SDKs for it, but who says you can't write a Julia SDK for it? But anyhow, maybe that's a discussion for another day. Yeah.
Regarding the no, that's not me. Regarding like visualizing what your model is outputting during training, I'm also adding, I don't think I have it documented yet, but to the deal pipelines, an interface for, I call it the interpretation interface, where you can basically visualize or otherwise make sense of the data. So like the unencoded inputs and then the encoded inputs and targets and the model predictions. And kind of give like an interface for that you can implement. And I've used it. And there's also a log visualization callback now on fluxtraining.jl that will put the images to TensorBoard, for example. And you can hook it up quite easily with a deal pipelines method and have that use that for the visualization function, and then it will always basically show the predictions at various time steps. And then you can use a throttle to only have it called every like 500 steps. I don't have a screenshot of it right now because I didn't take one, but I can maybe tomorrow send one on the Zulip so you get an idea.
Sounds awesome.
Yeah. I mean, on the Mach-E side of things, I have used that for like online visualization of something that I'm training, and then, you know, post-training being able to dive deeper into what happened over the course of that pipeline. But there's a lot of like wrapper code that I have to write that's very specific to the program that I'm writing to make that, you know, easy right now. The plus side of that is that when you're ready to publish a paper, Mach-E is like a really nice plotting utility to get those plots. So there's very little effort for me to convert that into a plot that I can publish. But yeah, I mean, that could be a really good long-term stretch goal, is to integrate with a visualization library like that. But I think, like Brian said, it really depends on what you're trying to do. Because there are cases where I would prefer to use TensorBoard Logger than to use, I mean, using Mach-E would, one, be a lot of effort, and also be really slow for some of the like online statistics. So it's easier to use TensorBoard Logger and more efficient.
Yeah, I want to point out here that you can, I mean, you can of course use TensorBoard for image visualizations, and they might even, I don't know if TensorBoard Logger.jl supports it, but I think there's an extension for 3D data that you can visualize as well, like 3D point clouds. And if you use the TensorBoard logging with Flux Training, for example, you can always, I mean, it saves the data to disk, and you can always read it back in to do visualizations after the fact if you want to make them fancier. So it's like a low stakes way of getting started and being sure that everything gets recorded in some way. That's I think a good way to start. And it also records any hyperparameters that you schedule, like learning rates. Brian added a PR to log the model histograms, like the histograms of the model weights, how they evolve over the training. And at some point, probably we'll also be able to log like the activations, delay activations, and the gradient intensities. Yeah, and save everything, of course. So you can always, I mean, TensorBoard is really, it's really useful and nice, but it's not the prettiest. But you can always.
Okay, well, I guess we are over time. So does anyone have any last minute things, or should we call it for today? All right, I guess everyone, thanks for coming, and see you in 2 weeks.
See you in 2 weeks.
Thanks, Aaron.
Yeah.
Bye.